is that we are going to learn some basic troubleshooting skills, but we are going to wrap it up with some activity, okay? So looking at this activity here, this activity is having so many problems, okay? This network is having so many problems. And we actually want to troubleshoot those problems and find them. And this is what we are going to end with. We have problems here with DHCP, problems with routing, problems with ether channels, so on and so forth. Problems with, I think, VLANs, problems with the DHCP, as I have already mentioned. So we are going to sort those problems one at a time. So this is an activity that we are going to do basically to talk about troubleshooting of our network. And we are going to employ tools that we have been learning so far, tools in troubleshooting, tools that we have been learning, you know, and the major tools we are going to use here are the show commands. Those are very, very important. So like I mentioned, let's look at some troubleshooting activities here before we can come back and basically work on that particular activity. So for troubleshooting an enterprise network, we'll explain how network documentation is very important in our network for the sake of troubleshooting. And then we look at the different troubleshooting methods. And we look at also some troubleshooting tools. And I'll give you an assignment to look at some of the symptoms, major symptoms and causes of network problems within the network and how to solve them, okay? And of course, we'll also look at troubleshooting within a layered model. And when I talk about the layered model, I'm talking about the OSI layer, okay? Now, a network documentation is a very important document in your network, okay? And this is a document that has very accurate and complete network information that is required to completely monitor and troubleshoot our network. So it contains all information about your devices, end devices, routing devices, so on and so forth, as we are going to see. And part of network documentation will always include the following. One, a network documentation needs to have the physical and logical topologies. They need to have a record of all the device information. And then they also need to have network baseline, okay? And every network documentation should always be kept in a single location and back them up, okay, in a separate location. Now, we have an example here of network documentation, and this is something that every network administrator, of course, needs to have. So I'll give you an example of the router device. This is for router documentation. You need to document what is the name of this device, what is the model, ISR 4321, what is the description, what is the location of this device, which operating system is running here, and where is it stored, and what is the version of that operating system stored in the flash memory, and what is the iOS image name. Of course, whereas the license is very important. Also note which interfaces are currently in this device, G00, G001, G010, so on and so forth. What is the description of each interface, as we have always done? What is the IP address of each interface? IPv4 and also IPv6. What is the MAC address of each interface here? Okay. And finally, which dynamic routing protocols? Is it static or it is a protocol like OSPF version 2 or version 3? Very important. So that is how you document a router. For a switch, you also need to have the host name, the model of this switch, 2690, 24 ports, look at the description, the switch, the management IP address configured on the VLAN 1, for example, or if you change the VLAN. The operating system image name is here. Is the switch using something called VTP, which is the VLAN trunking protocol? What's the domain name and what is the mode? Is it a server or a client? Look at the ports. Are the ports participating in ether channels or trunking? All right. Or access ports? Are the ports having any, are they on an access mode, switch mode access? Are there VLANs currently configured on this device? Is there trunking? The port channels there, what are their names? The native VLAN, is it available? And if the port enabled or it is shut down. So this information is very, very important for you to have. Now, what about our end devices? What do you need to learn about end devices? So like I said, end devices can be servers or they can be PCs. If you're a server, what server operating system is running? And what are the services it's running? Is it running DHCP, SMTP, FTP? If it's an end, a normal, client end device, is it running Microsoft Windows 10 for both HTTP and HTTPS? What is their MAC addresses? Very important. What is their IP addresses? Okay, version 4 or version 6. What are their default gateways? Okay, and what are their DNS addresses? Very, very important information that you need to have about your devices. So that is important there. And that is part and parcel of network documentation. Now, some of the most important tools for doing troubleshooting are your show commands, and make sure that, practice makes you perfect to be able to do this. So we have the show version command, which we have always talked about. If you want to display any hardware and software and even the uptime of your switch or router, use the show commands. Please note that all the show commands are always put at the privilege exec mode. If you have to put it at a level that is not privileged, then you have to begin with the word do. You say do show. Okay. We have the show IP interface brief and show IPv6 interface brief, basically displaying the brief listing of your interfaces. Show interfaces. Show interfaces mostly gives you an extensive detail of your device or of your interfaces, that is. Show IP route is used to reveal the IP4 routing table. Just like show IPv6 route is used to display the IPv6 routing table. But you can always say, if you need to display only static route, say show IP route static or show IPv6 route static. If you need to display only EIGRP routes, say show IP route EIGRP, or for SP route, SPF route, show IP route or SPF, so on and so forth. We learned this during the previous class. Show CDP neighbors detail. If you want to display information about other directly connected Cisco devices, including the IP address, then use the show CDP neighbors detail. To view the ARP table or the ARP table, show ARP or even show IPv6 neighbors. Very, very important. To view the current running configuration, show running -config. Okay. To view the VLAN information status in a switch, show VLAN. The status of ports on a switch, show port. And to collect large amounts of information using multiple show commands for technical support, reporting purposes, show tech support. Very, very important. Okay. Now let's look at the troubleshooting process and how does it look like, Now, Every troubleshooting process starts with some kind of gathering. So you need to gather always the symptoms. And you know how you gather the symptoms? You gather the symptoms using all your senses: vision, touch, smell, okay? And gather and use your show commands to be able to also do that. And you also need to have an understanding of your command prompt on Windows and terminal on Linux, okay? Because you want to see if your device, if the problem is on the end device or it is on a switch or router. So gather as much symptoms as possible. Once you've done that, you need to isolate some problems using your experience. And this is something that depends so much on your experience, okay? Isolate the problem, corroborate them, evidence you've gathered the symptoms, and try to point the mistake towards a particular point. Once you do that, implement some corrective measure. If it doesn't solve the problem, then you need to do much of data gathering, gather more symptoms, or it might actually solve the problem that is currently there. But if it solves the problem, then you need to document the solution and save your changes. Document the solution and save the changes. Now, troubleshooting can actually be done within the layers of the OSI, from the physical layer, layer 1, to data link layer, to network layer, to transport layer, to session layer, presentation and application. It's important to note that at the physical layer, this is where we have an older device called a hub. But at the physical layer also is where we have our network media, the fiber optic, copper and wireless, okay? At the data link layer, we normally have the Ethernet switch, the layer 2 switch, okay? At the network and transport layers, we have here routers, and we have the layer 3 switches here, okay? So it's important to note that at each and every level, there's a certain device that does perform some special functions. And for application presentation and session, the end devices are majorly found here, and you might want to check so much about them here. Now, let's look at some structured troubleshooting methods. And for here, we are talking about different methods that you can learn, again, depending on your experience, okay? And to start us off here, we are talking about basically we start with the bottom up, okay? And so the bottom up approach we are talking about here is actually starting from the physical layer, which is the layer at the bottom, climbing to the data link layer, the network layer, all the way to the application layer, okay? So you start here. If you suspect that the problem could be at the physical, then you do the bottom up and you move up quickly. Of course, we have the top down, which is an opposite approach. So if you think the problem is software related and it might be on the end device, then you're actually going to start at the application, presentation and session, because that normally starts at the application layer on end devices. Then we have another method called the divide and conquer, okay? So for the divide and conquer, you actually start in the middle, probably at layer 3 or layer 4, and then you do your test on both directions, okay? That is divide and conquer. We have follow the path. Majorly, these ones could use something like trace route or something like that, whereby you discover the actual traffic path from a source to a destination to reduce the scope of troubleshooting. You want to make sure to identify which device is actually dropping packets and why, okay? And applications like traceroute or traceroute will do that very well for you. Now, we have a method called substitution. in substitution, you actually substitute or you swap. You swap a working problem, a working device with a problematic one. Okay, so get a working one and put it in place of the one that is having a problem, and you can sort it on the side. Then you can also have a method called comparison, whereby a device that you have configured with the correct commands, you compare it with another device and try to check where exactly is the problem. Okay, or basically you compare a non-operational element with a working. It could be the commands you have stored on some notepad somewhere, and trying to check where had you gone wrong. Now, very seasoned network administrators, very experienced, they choose to go with the last method, which is called an educated guess. Okay, and here again, depending on your experience, you could just look at the physical behavior of a device, router or switch, and this person will definitely know where exactly the problem is. That's an educated guess. Okay. Now, as part of the troubleshooting process, there are different tools and softwares that are always used, and we are talking about port analyzers. And a very good example is the Wireshark. Wireshark is such a brilliant tool, because it will always capture and display the physical layer to the application layer information contained within the packet, and that is a very good thing. All the layers of the OSI will always be displayed here. And looking at this diagram here, I could just give you a small. If you click on it, has normally 3 parts or 3 rows. We have the first row here. We always have the third one here. These are actually, yeah. And then we have the third one here. So looking at this particular packet capture here, you look at a frame here, and you already know that is the data link layer. Of course, together the Ethernet layer here. You look at the internet protocol here, version 4, and you say that is the network layer. Look at the network, the user datagram protocol, UDP, and you know that is the transport layer. Okay, and it goes like until you reach the other layer. So it's important to note that Wireshark, it's such an important one for, and the other day I think I did demonstrate this, and I'll probably do a video on it as well, on how to analyze traffic using Wireshark and how to differentiate SSH from Telnet in terms of capturing the two networks. And so it's important to always do that. Now, let's look at an example of troubleshooting an IP connectivity network. And so we do this on an end-to-end connectivity on a device. And we're going to choose just one of the method, the bottom-up approach. And we realize that there's no end-to-end connectivity. And these are the following that we are going to do. Remember, bottom-up starts from the physical layer. So you need to check your physical connectivity, check on your cabling. Okay, are the cables broken up? Is the cable correctly fitted on the port? Is the RJ45 connector well, or it's broken, or it's not terminated well? So those are the physical parts of this network that you want to check. You basically want to check if the device is powered on, it's having power. Okay. So after you do that, move closer and now check the duplex mismatches. Do you have the cable, maybe one side is half duplex and the other side is full duplex, or what's happening? Then you might also want to check the data link layer and network addresses. Check is the MAC addresses land on the switch MAC address table or not? Okay. Is the IP address correct? Okay. Is the default gateway, is it the correct one or it's the wrong one? Did the device pick up the correct IP address from the DHCP server? Very, very important. Okay. Check on the ARP table of the PC. Did it get the correct and even the routing table of the PC. Did it get the correct path from the source destination? And also at this point, you need to check the routing table of the routers, okay? And check that there is correct routes within the routing table. Check on the transport layer that is functioning well. You could do an NS lookup process. You could do some ports that have been learned as well. Verify at layer 4 that there are no SCLs blocking traffic. That's very important. And check your DNS as well as part of the applications, that the DNS settings are actually correct and the device, either it was configured well with the correct DNS address or it acquired the correct DNS from the DHCP server. Okay. Now, I want us to work on this. There's so much explanations within the account. They give you so many symptoms within the account. And it's, they're just there for reading purposes, and they actually want you to go through some of the symptoms. So I would definitely advise you, go and read on this 13th chapter on troubleshooting. Read through those symptoms and how to solve them, okay? Now, what I want to do right now is that I want to open this troubleshooting enterprise network packet tracer, and we're going to troubleshoot so many things. And I think this is going to form, the end of our class today until next week, okay? Now, let me just, of course, open up that packet tracer, and I want us to basically working on it together and basically seeing that everything is actually working on this network. And as always, as we correct any problems, we get more marks added here. This is one of the best packet tracers that I will always want anyone to lay their hands on, okay? So I'm gonna zoom it, but if I zoom it, it will not going to be fit here, all of it. So we are not going to see everything, but I'll always be ready to slide it left or right. So reading on the background of this activity, we are told this activity uses a variety of technologies that you have encountered during your CCNA studies, including IPv4 routing, IPv6 routing, port security, Ether channel, DHCP, and NAT. So your task is to review the requirements, isolate and solve the problems, and then document the steps you took to verify the requirements. Okay. The company replaced routers R1. Okay. The company replaced routers R1. You can see our 3 routers here. This is R1, R2, and R3. Okay. So the company replaced routers R1 and R3 to accommodate a fiber connection between the locations. Configurations from the previous routers with serial connections were modified and applied as a starting configuration. IPv6 is being tested on a small portion of the network and needs to be verified. Passwords have been removed for the ease of troubleshooting in this exercise. The typical password protection should be reapplied. However, the activity will not grade those activities. So what we want to do is as follows. Of course, we are given a brilliant IP addressing table here with the R1, R2, R3, which is some route on a stick. And then, of course, you see the fiber optic cable, this one that was replaced here. This one has remained a serial cable, okay? So we have IP address table here, which is one of those that we're going to be checking at. But we also have the instructions to guide us here. And we are going to follow those instructions as they were. So the first instruction, you're told to verify switching technologies. And the first one is called port security, which we all have studied before. We are told port security is configured to only allow PC1 to access S1's F03 interface. All violations should be disabled should disable that interface. So issue the command on S1 to display the current port security status. So I'm gonna do that on S1. I hope you will be able to see it because I have been able to zoom in. So I do enable, I do configure terminal. Okay. Well, I can actually do exit to go back to privilege because I'm using more of the show commands. So I'll say show port security. And I press enter, and currently S1 does not have any port security configured. And that is something to worry us about. So it means that if port security is not even enabled here, I will say show port security interface F0/3, because that's where I do to check it. And if I do that, you can see that port security is disabled on this interface, and that means we might need to configure it. So I do configure terminal conf t, and then I say switch port. I go to that interface. I say interface F0/3. I say switch port security to enable it. We have 4 marks already. Then I was told that all violations need to be disabled on the interface. That means should disable the interface. That means the interface should be the violation should be shut down, which is the default one. You can see that here. But we're also told that port security is configured to allow only PC1 to access that device. Okay. We are told to enter the interface configuration mode for interface and set up port security. So we are given the commands here. So we say switch port security, MAC address sticky for the sticky MAC addressing. What did I do? MAC address sticky. Sorry. Yeah. And we have 8 marks. The next instruction is saying that devices in the LAN on S1 should mean VLAN 10. LAN on S1 should be in VLAN 10. Display the current state of the VLAN configurations. Okay. What ports are currently assigned to VLAN 10? So let's do that. I do Control Z and I say show VLAN brief. Yeah. When I do that, and I might want to expand this so that we can be able to see that very clearly. Now, if you look at it currently, VLAN 10 is, the name is called V10, and currently port F03 and 4 are under it. But remember, one of the ports that need to be under it is, of course, is 3 here. And maybe this is also a very good time to check so that we see which ports are currently assigned to VLAN 10. So the devices in the LAN on S1 should be in VLAN 10, current state of VLAN configuration. Now, let me just say here, show IP interface brief. And look at show IP interface brief. I can see that only port F03 is currently active. Okay. And continuing down here, the only other port that is active, of course, is G01. So when I did the one for the VLAN, port F03 and 4. Okay. So I don't know where this port 4, because it's not connected to any device. Why is it on VLAN 10? Why is it why is F04 under here? And I don't know, I can remove it there. I don't know that it will reduce our marks, but let me see what ports are currently assigned to. Okay. So let me just say, let me go to that port. It was interface F0/4. I will say no switch port access VLAN. Nothing happened. So it's okay. It's okay. I'll just leave it like that. They're saying that PC1 should be receiving an IP address from the router R1, and that is a very important point. PC1 should be receiving an IP address from the router R1, which means that we need to go to PC1, go to desktop, and go to IP configuration. And looking at this part here, ladies and gentlemen, as I've always said, this PC did not receive a correct IP address. It receives an APIPA, which is 169.254.171.125. And this is not very good news. Okay? So we need to work very hard to see what is the problem. Is the problem with the DHCP server, or what is the real problem here? The PC has an IP address, as you have seen, but that PC is not currently, yeah. And so we are told here that we notice that G01 interface on R1 is not in the same VLAN as PC1. That is very correct. So we need to change the G01, this interface, to be a member of VLAN 10 and set the port first on that interface. Yeah, that is the point we were missing. So this interface here, G01, because when you did here, when you did say do show VLAN brief, we realized that G01, the one we were here was actually F04. So I can actually return it there. I could say switch port mod access, and I say switch port access VLAN 10. So that when I say do show VLAN brief, the F04 is there, but I also need to make G01. So I will say interface G0/1. I want to make it an access port. So say switch port mod access. I say switch port access VLAN 10, and I will say spanning tree, and set port first on the interface. So to set port first, we say spanning tree, port first, spanning tree, port first, and that is actually going to make it to be there. Now, we are told to reset the interface address from PC1, from G01, and we need to minimize this. We have to reset the interface PC from GUI, or by using the command prompt and set IP config. So what are they saying? They're saying we go to the PC here. We either come here and say static, then we come to DHCP, or we go to the command prompt and we say IP config space / renew. Okay, those two commands should be able to give the IP, any of those ones should be able to provide the IP address. So I could do this command, or if I like the GUI, I'll just go here, take it back to static and bring it back to DHCP. And let's see if it's gonna be receiving an IP address. Just give you a few seconds. And look at that, ladies and gentlemen. It has picked the correct IP address, 192.168.10.10, subnet mask here, and default gateway is here. Of course, that gives us an opportunity to go to the router and check the DHCP configuration here. I could just say show running configuration, and you could see that 192.168.10.1 were excluded up to .9, and the DHCP pool name is LAN 10. The network address was 192.168.10.0, and the default router is 192.168.10.1. Okay, so everything seems to be okay. And that's our device has actually acquired the correct IP address. So we are told that does PC1 have an IP address? If not, recheck your steps. Test connectivity to the FTP server. The ping should be successful. So this is the FTP server. From the PC here, I need to go to the desktop, the command prompt, and then I need to ping the TCP server. And I'll just say ping 192.168.20.254. And clearly, we wait for the replies. There. Maybe sometimes I could just hook this one here, and I could press, yeah, it's coming, fast forward to see if I will receive, I will be able to, yeah, clearly you can see some replies here, ladies and gentlemen. And yes, we do have replies from that particular server. We lost one and we got 3. If we do it again, you'll get the 4 replies all together. Okay. Correct. You can see our 4 replies are actually available here. Now, the next thing that I want us to talk about, of course, to check on as we, of course, check on this is the fact that, I mean, it's important, of course, to do that. So shooting, okay, is we want now to check on something on ether channels or the ether channel summary, ether channels or the ether channel summary, because that is going to be very, very important for us. Okay. Now, having checked on that, let's look at what is here. So we are told the LAN connected to R3 had an additional switch connected to the topology. I think you can see the LAN connected to R3. Yes, R3 is where we find also, of course, the ether channels, and we need to troubleshoot some kind of, the ether channels there. So that LAN had some ether channels, and we definitely want to check that everything is well okay. Now, just making sure that everything is okay here. So you can see the ether channel network on the right hand side here, and we need to test this group here. Now, link aggregation using ether channel is configured on both S2, S3, and S4, and you can see that here. The ether channel links should be set to trunk, very important, and the ether channel length should be set to form a channel without using a negotiation protocol. Very, very important. That is the on. Okay. The on is, it doesn't tell us whether it is PAGB or it is LSCP. So there should be no negotiation, but the trunk should form. So issue the command on each switch to determine if the channel is working correctly. So we could start with S2, for example. And we're gonna say here, show ether channel summary. And checking at the ether channel summary here, you can see that this switch has port channel 1 and 2, that is switch S2, as port channel 1 and port channel 2. Okay. and F01 and 2, F03 and 4. 1 and 2 on port channel 1, and 3 and 4 on port channel 2. Okay. We need to do the same for S3. So we do here and here, show ether channel summary, and there's a problem here. Yeah, port channel 1 is not configured on S3. So that's one other thing we need to do. S3, where is S3? Yes, port channel 1 is not there. I guess it will be port 1 and 2. So we might want to say here, const T, say interface range F0/1 to 2. Okay, for that problem we found. The best practice is always to shut them down. Shut them down. Then you get to say channel group and should be channel group 1, and the mode should be on. The mode is on for this one. And we have 33 marks so far. And then we say no shutdown. No shutdown. Yeah. What did I see here again? All right. Once you do that, then let's check now again. Do show it channel summary. And you can see it has been restored. And now we have port channel 1 in use and port channel 3 also in use, no protocol at all. Okay. It's also best to just check on this our switch here. We'll say show spanning tree. And in say show spanning tree, of course we look at each there's different VLANs, VLAN 1, there's VLAN 11. They have different roles, designated roles. Here we are having, of course, alternate roles and root ports and so on and so forth. Maybe that's not very important now, but let's check on switch S4 and look at show ether channel summary. Okay, we realize that this switch is actually okay. F01 and 2 and 3 and 4 are port channel 3. So port channel is pretty working well now. And then we're told to check the stable status of F03 should be stable now. Of course, it takes. All right. Then now we go to verify trunk status on all switches. So on S3, let's check at show interface trunk. Show interfaces trunk. So checking that, we see that the trunk here, let me just zoom this in again. So trunk encapsulation is 8221Q. So it's trunking, and the relative VLAN is VLAN 99. Okay. And VLANs allowed, of course, here 1, 11, 30, 40, 50, and 99. So that seems to be working pretty well. Let's look at F02. Show interfaces trunk. And looking at 802, There's something missing here. You realize that the native VLAN is 99 for the trunk on port channel 1. Port channel 2, the native VLAN is 99. But there's a problem here. G01, the native VLAN is VLAN 1. And I think that can be a problem. And checking at S2 here, the native VLAN, I think, is G02, I think, is connected to the router here. Okay. And that needs to be a trunk. And I think we need to put the same native VLAN all over so that they could be transferring that information. So we definitely need to go to interface G01 and we say switch port mode trunk. Okay. Switch port. Oh, sorry. Trunk. Then you say switch port trunk native VLAN 99. That is very, very important. Then we need to go to spanning tree now. We are told that spanning tree should be set to per VST on S2, S3, S4, S2, 3, and 4, okay? S2 should be configured to be the root bridge for all VLANs. Issue the command display the spanning tree status on S2. We are still on S2, so we'll just say do show let me just go to the privilege exec mode. So say show sorry, spanning tree summary totals. And we do that, we realize that the current spanning tree here is actually put on per VST mode, okay? And the root bridge, I think it's having an issue here, and that is something very, very important. So to enable this switch to be the root bridge for all the VLANs, okay, we need to set it to the root primary, not secondary. If you set any switch to a root primary, of course, you could either do that using priority values, or you set the root to primary, it will be the root bridge for all the VLAN. So we say it will put the command. The command output shows that S2 is not the root bridge for any VLAN. So we need to correct the spanning tree status on S2. So that means we need to go to global configuration mode, and we say spanning tree. All the VLANs, we have VLAN 1 to 1005, and we say root primary. Okay, we say root primary. My switch is just hanging a little bit here, but it will be up in a moment. I don't know why it's doing that. I think this packet tracer file was very huge. Okay, so that's so when I go back here and I say show spanning tree summary totals, I should now have spanning tree here is per VST mode, and the root bridge is the default for VLAN 30, 40, 50, and even the native VLAN that is there. And that is a very good sign there. Let's go to troubleshoot DHCP. Now we are told that DHCP here, R1 is the DHCP server for R1 LAN. So again, right here, R1 is the DHCP server for this R1 LAN. R3 is the DHCP server for all the 3 LANs attached. R3 is the DHCP server for all 3 LANs attached to R3. Okay. We are talking about the 3 LANs because I think we have them right here. I need you to see that. We are using VLANs, and so this should be VLAN 30, this is VLAN 40, and this is VLAN 50. And the VLANs are actually LANs on their own. They are segregated. Okay. So we are told that to check the addressing of the PCs, we know that PC1 was having the correct IP, as we can check again. And you see it's having 192.168.10 something, and the default gateway is okay. DNS server is what was not there, but I can't see any DHCP server here. I don't know that there is. No, there isn't. I can check from the table if there's a DNS server. No, there's no DNS server. Okay, let's troubleshoot DHCP. So let's go to this PC2 here and we check the IP addresses. PC2. Remember, PC2 is on VLAN 30, so I expect them to have 30 something. I go to here and check IP configuration, and yes, it's okay. This device is having 192.168.30.10. Default gateway is 30.1. That's okay. PC3 IP address should be on network 40 something. And look at here. Look at this. Let me just zoom it. The IP is correct, 40.10. But look at the default gateway, 30 something. This is wrong. It should be having 40.1. And that's a problem we need to solve for PC3. Probably the DHCP server was configured with the wrong default gateway. If you check PC4, and PC4 is also having a problem here. PC4 is now on VLAN network 50, but its default gateway is 30 something. So that's a problem because they receive them through DHCP. We need to go to the DHCP server, which is R3, and just view the show run button. Should be able to give us back some good command. So we say show run, and looking at the show run, we excluded the addresses very well. The only problem is, let's look at this, where the problem is. We can see that for LAN 30, IP address is network address is 30.0, and the default gateway is default router 30 something. Look at LAN 40, the network address is 40.0, but look at the default gateway, how it was configured 30.0, and that's one thing we need to set. The same as LAN 50, and the default gateway is 30. So they took the one for 30. They just did things so wrongly here, and that's what we need to correct. So we need to say conf t, then you say IP DHCP pool, and you put LAN 40, and we say default hyphen router, and you say 192.168.40.1. That's correct. And you go to LAN 50 and you change it to 50.1. So we say exit here, and you say IP DHCP pool LAN 50. Yeah, and you configure the default router. We say default hyphen router 192.168.50.1. That is the default router, the default gateway. And we need to go to those PCs. Okay. And we go to this PC, I think was okay. Everything good. PC3 is where we are having the problem. Okay. So we need to change it to static and return it back to DHCP. And let's see it acquire the correct IP address. And here we go. 40.10 is the IP. Default gateway is 40.1. We have 61 marks now, and that's a good one. Let's go to PC4 that was having another problem here. It's still having 50 and 30. as we had seen, we need to reset the IP address. We need to reset the IP address, and we do that. We take it to static, then take it to DHCP, and boom, it acquired the correct IP and default gateway. Okay, and it's successful. And now we are told, why are you able to ping all IP addresses? So probably we could test to ping maybe from PC1. We could ping the server from the TFTP server from PC3 and maybe 4. So I go here and I just say ping 192.168.20.254. And you can see replies being received as usual. I don't know that we can be able, so if it can do that, then it can do ping any other device. 64.100.100.10. Okay, host is still not reachable. I think for that we'll need to test something on it. Let me test. So long as it's able to ping a device on the other end, that should be okay. Because we have it troubleshooted other parts of the network. So we'll say ping 192.168.20.254, and we are receiving replies. So the fact that we're receiving replies from PC3 and 4, which were having wrong IP addresses, all the way to the server, about 4 or 5 networks away, that is a good sign. Let's move on. We have already pinged to check the connectivity. Let's now verify routing, and there must be a problem here. And what we are doing here, basically, is on routing, which is serious, it will verify that the following requirements have been met, if not complete the configurations. All routers are configured with OSPF process ID 1. No routing update should be sent across interfaces that do not have routers connected. Those are passive interfaces. All routers are configured OSPF process ID 1. No routing update should be sent across interfaces that do not have routers connected to it. So that's exactly what we need to do. So we're going to start with R1, because we don't know which router specifically. Then we're going to say show IP route. That will not give us a very good one. We need to say show IP OSPF process. IP OSPF interface in R1 should be I need to check all interfaces at the same time. That is going to help us here. So we start with interface G00. Here, it has the correct IP address, and of course it's a BR here. And yeah, I want to just come show IP protocols. Okay, and showing IP protocols, the only passive interface in R1 should be the only interface that doesn't go to a router, which is G00. And you can see the passive interface here is G001. Yeah, it should be G001, and that is actually correct. Okay. And of course, process IDs here is 1. Those are the only 2 things we are told to check. And then the next thing we do on R2, we put the same command, and we say enable, say show IP protocols. And the IP protocols command, we are basically checking that process ID here should be 1. You can see process ID is 1. And since this is R2 should have two interfaces, G00 and G001. Should have those interfaces, put as passive, G00 and G01. And if we look at this part very well, passive interfaces, I can't see any here. And that's a problem that we need to have. Yeah, that is a problem that we need to check here. So we could do here conf t, and we'll say router OSPF 1, and we say passive interface G0 /0, comma G0 /1. I don't know whether that is going to work. That's not recognized. I need to do enter, and I do G01, and I enter for that. So that when I now say show IP protocols, I should now see the passive interfaces well stated here on R2. And then I go to R3, we should also have only one passive interface, G01. So I go here and I say show IP protocols. And on R3, here, what I am basically having here is there's no passive interfaces here. So that is the other thing that I'm going to do. I am going to say conf t, and I need to set that interface to be passive. That is interface G01. So I say router ISPF 1. What is the process ID? Okay, process ID is 1. That's correct. And then I say passive interface G0/1. And I say do show IP protocols. I should see a passive interface here, G01. Okay. Now, I was also told that R2 is configured with an IPv4 default route pointing to the ISP, and to distribute the default route. Okay. Distribute the default route there. All right. 8. Okay. So moving forward here, we are told that R2 is configured. So we can actually check that on R2. We could do a show run. Show run. And we will see the passive, the default route. Okay. And I can't actually see the default route here. All right, a default route. IP route. All right, I can see IPv6 router, SPF1. Yes, IP route, it's here. And even IPv6 route. Yeah, so this is our IP route command, and it should be pointing toward G00. We could see that. So we are told it should point to the ISP R2. Should be pointing towards G00, and that is correct. IP route G0.0.0, 0.0.0, and the exit interface is actually G00. That's okay. And should distribute and retribute the default route to in ISPF version 2 domain. So I can't see that command here. It was supposed to be in, let me look at ISPF configuration. Default -information originate. I cannot see that command here in ISPF. So that is the other thing we need to pay attention to. So we will need to go to R2. I say conf t and say router OSPF1, and I say default information originate to distribute that static. That's one thing that was missing. And then R2 is configured with a default IPv6 fully qualified default route. And that is what something we saw up here. See IPv6 right here. IPv6 route :/0 fully qualified means fully specified, should be fully specified or fully qualified. It must have an exit interface, and it must also have the next hop IPv6 address. Okay. And redistribute the default route in the OSPF domain. So that is what the other thing we need to check. Okay. So we need to check that. So the next hop IPv6 is actually this is for R2 still. It's facing towards the ISP. Of course, the exit interface is G00. That's correct. The next hop IPv6 is 2001:db8:8:219.1. I have no idea, but it is already configured. But we are told that it needs to be redistributed. So exit here. I need to say router IPv6 okay. Yes, I'll be on in a minute here. Okay. Okay. All right. Sorry about guys. Was a slight problem there, but I'm back. Sorry about that interruption. Okay. So I was here, part of IPv6 routing here. And so R2 is configured the default IPv6 fully supported default route and need to be distributed the default in the OSPF version 3 domain. NAT is configured on R2 and no untranslated addresses are permitted to cross the internet. Check the routing table on all routers. Okay, so okay, small problem. We are almost done, guys. Let me just check the routing table in R2. Okay, yeah, I think this is what I was looking for. IPv6 router.
I can't see.
Oh, okay. Sorry about that, guys. Okay. Yeah, you should be able to see it now. Yeah. So what I was saying, we had already distributed the default route in IPv4. We now need to redistribute it in OSPF version 3. So we say router OSPF. So we say IPv6 router OSPF 1. And you see that that is OSPF version 3, which is for IPv6. Then you just say default information originate, and that is actually done. Okay. We can check the routing table, say show IP route, and there are so many routes here. Probably we could say show IP route OSPF, and you only get to see the OSPF routes here. We could say show IP route static, and you only see the default static routes here. Okay. We're told to check the routing table on R3 and R1 and R3 to make certain default route is present. So we need to go to R2. We need to go to R1 and R3. Sorry. So R1, let's check that the default route is actually present here. So show IP route OSPF. So we need to see the route that was learned with OSPF. This is the route we did. Those who are in that practical, we did the other day. We can see that this is a static route because you see it by the asterisk. It's a default static route, but it has been learned through OSPF, and it's an external type 2 route imported into OSPF. That is very important. We need to see that in R1 and R3. So in R3, if you look at the show IP route static, we can't see any routing table here. And that means there's something that we need, show IP route OSPF. We can actually see that OSPF route is actually here, the external route there. We also told that test IPv6 connectivity. Okay. Test IPv6 connectivity from R2 to the outside network. From R2. So we need to ping something from R2 to the outside network to test IPv6 connectivity to outside host and TFTP server. So I just need to ping here. And the outside network we're testing IPv6 is 2001 :DB :DB8 :B :64. I hope you can see that address on the outside host here. :10. And clearly you can see that there's 100% here. That is very good. Let's do the same for the TFTP server IPv6 address. You see IPv6 is very fast, faster than IPv4. 2001 :DB8 :B :20 :254. And you can see 100% return here. Very, very important there. IPv6 is very, very fast. The next instruction here we are being given, we are told to test IPv6 connectivity from R2 to PC4. If the ping fails, be sure to check that IPv6 addressing matches the addressing table from R2 to PC4. So PC4's, we need to, let me just hook R2 here. So I need to test to ping PC4. So let me open PC4 here, and I go to its IPv6 address right here. And I'm gonna pick what is here. I don't know whether it will pick it, copy it, that's correct. And I'm gonna just want to ping it here. And when I just click paste here, the success rate is here. I can be able to reach that PC from the router. So I was also told that I've already tested that PC4. We also told here that test IPv6 connectivity from R3 to outside host. If the ping fails, check IPv6 routes on R3. Be sure to validate the default route originating from R2. If the route does not appear, modify IPv6 or SPF as soon as possible. Anyway, so let's test from PC R3 to outside hosts. So this is that. So from R3 to the outside host, I need to ping IPv6 there. So ping 2001:B:64:10. Clearly, you can see that we are receiving 100% success rate here. And that's a very good sign there, having distributed the IPv6 route. Then we are told to check connectivity from R2 to the outside host. The ping should be successful. We already did that, and it was actually successful. We are almost done. We want to verify one technologies now. So looking at what is given to us here, we're told the serial links between R2 and R1 and 2 is used as a backup link in the case of failure and should only be carry traffic if the fiber link is unavailable. So let's just see what they're saying here. They're saying the serial link between R1 and R2. So this is R1, this is R2. This serial link should act as a backup link in case of failure and should only carry traffic if the fiber link is unavailable. This is the link between R1 and 3 and between R3 and R2. Okay. That means there's be some floating static routes there. Then I told Ethernet links between R2 and 3. R2 and 3, sorry, between R2 and R3. These links here, which are using fiber, is a fiber connection. Okay. And I think we could check some of those things moving forward. So the serial link between R1 and R2 is actually used as a backup. So we could just go to R2 here, or probably let's go to R1 here, and we could do a simple show run. And we look at what is the current route traffic going to probably, let me see this on routing. Let me go to routing. So static routes majorly. We didn't have any static routes here. I think they should be in R2 probably. Show run. Let me go to static routes that were configured in R2. All right, so the IP route commands. So IP route here. So I think it was the default route, most probably on R, but that was going to the internet. And just an access controls. Anyway, that's okay. So we'll see that slowly by slowly. So Ethernet links between R1 and R3 is fiber. So let's look at R2 and R3. R2 and R3. We look at interface G010 on R2. Interface G010 on R2. So show interfaces G0/1/0 and look at the interface type here. So it's a gigabit Ethernet here, and the media type here is terminated with RJ45, is 100 Mbps, and we are trying to look at the interface types here, and okay. Hardware is CN here, gigabit Ethernet, and I think that CN should tell us something there. There's a word I'm just forgetting on seeing these interfaces here. Yeah, normally fiber optic comes in single mode fiber or multi-mode fiber. There's transmission load and the receiving load, and the device is connected. Okay, that's okay. And then I'm trying to look at the Ethernet link between R1 and R3 is a fiber connection and should be used to forward traffic from R1. Okay, take a closer look at the routing table on R1. Are there any routes using the serial link? So R1, use the tracer command to verify any suspicious path. So let's go to R1. Use R1 here. This is a real, ladies and gentlemen, this is a real troubleshooting process, and this is what you do in the field. So let's do a trace route to 192.168.20.254. We are tracing the TFTP server from R1, and we want to see if there's any device using the serial link, since it is supposed not to be used. So if you look at our TFTPs, our trace out, excuse me, look at our trace here, you realize that our network is used 10.1.1, which is actually being used here. Traffic is actually moving from R1 through S010, okay, then to network 20 here, all the way to the server. So this is what they are actually refusing, and this one should not happen, okay? So I can actually see the results that we have received here, right here. Traffic is clearly passing through the serial connection when traffic should be going through the fiber optic to R3, then to R2. So reading the instructions we are given here, we are told clearly there's suspicious traffic, okay? So notice that traffic is being sent via serial link 010 interface as opposed to G00, which is the one passing through going to R3. So the original configuration that came from the previous serial 1 connection were transferred to the new devices. And this is a mistake that can normally happen even in our network. So we are taught to compare G00 interface and serial interfaces settings. Notice that they both have an OSPF cost value set. Remove the OSPF cost rate setting from the G001 interface. It will also be necessary to remove the settings on the links on R3 that connect to R1. So let's first start by seeing here in R1, we want to look at OSPF settings, and look at show IP OSPF interface G0/0/0. This interface for R1 is this one. And let's see those settings that they're telling us. Okay. So let me just retrieve that here. And you realize that the cost value here, 648, wasn't supposed to be here because this is a G0 interface. And so we need to remove that cost value. So because the cost is on interface G00, we need to remove that cost of 648. So what we do, we say interface G0/0/0, and we say no IP OSPF cost And the cost was 648. Yeah. Let's enter. And we need to do the same to R3 on the other end of that connection. This other connection, we need to go to R3 on G010, and we do the same thing. But we need to first see that it is actually there. Show IP OSPF first. No, show IP OSPF interface G0/1/0. And clearly see the cost is 648, and that's what we need to remove. So conf T and say interface G0/1/0. We say no IP OSPF cost 648. Yeah. And then once you do that, we need to reissue the traceroute command from R1 to see if the thing is still the same. So Control Z and say traceroute 192.168.20.254. And clearly we can see something here that the route has changed. Now the route is passing through network here. Let me just reduce the size here. Traffic is now passing through network 10.3.3.2, which is the network between R1 and R3. Then it goes to 10.2.2.1, passing through R3 and R2, and then it goes to the destination device 192.168.20.254. So traffic is now moving through here, and that is one thing we needed to solve. All right. Now, the change has been made to direct traffic over the faster link. Obviously, fiber optic cable is faster than the serial link, okay? However, the backup route needs to be tested. So shut down interface G02 interface on R3 and test the connectivity to the FTP server and outside. So on R3, right here, I need to shut down, look at this. I need now to shut down this interface so that we see if traffic, okay? We need to shut down this interface and we see if traffic is going to follow this other side. So I want to just shut down that interface. So I just say interface G0/2/0. I say shut down. That's okay. And then now from here, I actually need to test connectivity to one is to the outside server. So I do Control Z and I say a trace route. I need to test connectivity. I could just ping them, or I could actually trace route. They are the pings. So let me say ping 192.168.20.254. Yes, correct. It is going through. And then 192.160, 64. The outside host is 64.100.100.10. And we see here, the first one was 100% success. The second one is kind of dilly-dallying. I think we needed to test for IPv6. Let me test for IPv6 and see if that is actually correct. R2 not, I think R2 is not doing something. Let me ping IPv6 2001:DB8:B:64. What did I do again? :10. Even that one is not going through. So the pings are not successful for a host route, but they're successful for the server. So R2 is required. I think we need to do some NAT thing here to translate the public to private. I think that's why our device is not pinging the host server. So R2 is required to perform NAT on all inside internal networks. So check the NAT translations on R2. So bring R2 this guy here, and we do the show IP, not translations. There's no translation that has happened at all. So we are told that notice that the list is empty, as we can see here. And if you have any attempt to ping from R1, attempt to ping from R3 to outside host and recheck the NAT translations on R2. Issue the if you have only pinged from R1, because of course we need to ping from R1. Let's ping from if only ping from R1. So let me ping from R1 then, and ping here. The outside host is 64.100.100.10. Sorry. And the pings are also not going through. That is bad news for us. So we need to have a check at it. Okay. Now, so we are told that, of course, the pings are not going through. We had already attempted pinging from R3 to the outside sort and recheck NAT translations. We need to issue the command to display the current NAT statistics, and which also will provide the internet involved NAT. We'll also provide the interfaces involved in NAT. So on R2 here, this is R1. Let's go to R2, and let's say show IP NAT statistics, and you can see the interfaces participating here is for the outside host on R2. Let me just minimize this. So G00 is currently the outside interface of R2 only, the outside interface of R2, while the only inside interface of R2 is G01, which is this one, G01. You know what we want to do here? When we did talk about NAT, we said if this is the only outside interface having a public IP, interface S00 and G01010 should also be inside interfaces. And that's why we are going to make S00, in this case, to be an inside interface on R2. So we do conf T, okay? And so when we do conf T, we need to say interface S0/0/0. We say IP NAT inside, IP NAT inside, and to test connect from outside from R1. Now we can see and see if that is actually working out. Let's now be able to ping, and you can see the pings are now going through because the packets are being translated at R2, and we can also ping from R3, and right here, sorry, that is IPv6. I think they are not being translated. Let me check the one for IPv4. Okay. Oh, IPv4. Oh no. Yes, that one. You can see its traffic is actually moving. And if we check the R2 where translations are taking place, and we say show IP NAT translations, and you can see there's a forest of translations that are happening here, just like we saw the other day when you did the lab for when you did the lab for this one, we actually realized that translations were happening, and these are ICMP, and you can see the inside host address here, 10.1.1, and the translations being done here on 200.225, and the outside local, of course, the device we are pinging, and we ping several devices, and probably, Yeah, so that was actually working as well. Now we have 93% here. We are told test connectivity to outside host from R1. The ping should now be successful. Re-enable the G02 interface on R3. Of course, we need to re-enable the G02 interface on R3 here. So conf T interface G0/2/0, and we said no shutdown, and it is activated. But I realized that we also needed to go to R2 and put that interface also and say interface G0/1/0 IP NAT inside. IP NAT inside. We needed to do that on R2. Now we are told that verify connectivity devices should now should be configured according to the addressing table. Every device should be able to ping every other device internally. The internal PC should be able to ping the outside host. PC4 should be able to ping the PC server on the outside host. Now we need to check that very quickly because we have 93 marks here. We could do check results to see where the problem is, and you can see that we needed to do the passive interfaces for R3. This is serious. R3, we needed to say passive interface, not just G01, but we needed to do it on the sub interfaces on R3. So we go to R3 here. We go to exit out of the interface and we say router OSPF1 and we say passive interface and we put on R3, we have G01, G0/1 dot 30. Then we have G0.1.40, G0.1.50. Okay, and maybe .99 is not a physical interface. So that's it. That's why we didn't get 100% there. So guys, that was all about this troubleshooting stuff. You've done everything so well. And since we got 100%, everything should now be working well. But you should never assume that. If you should be able to at least do this setting, though I'm certain because we're using a simulated environment, I am certain that everything was able to be solved very, very well. So you might want to just retake this. And this is actually lab 12.5.13. 12.5.13, you could note down that 12.5.13. And because I want to give you more assignments here, having gone through 12.1.13, 12.5.13, that is, please also work on 12.6.1, which is a troubleshooting challenge, 12.6.1, and 12.6.2, 12.6.1 and 12.6.2. Those will give you a good challenge. So we meet next week. And when we meet next week, we'll be talking about our next topic, that is on network virtualization and network automation, that is 13 and 14, the final ones. Otherwise, I think this was a very engaging activity, and I hope to see you in the next class.